Hello everyone. Today I'm pleased to share our recent work for INDIN on learning-based vehicle sequencing for on-ramp merging in mixed traffic. While single vehicle intelligence like end-to-end self-driving has advanced significantly, data shows congestion in megacities is still increasing. We view traffic control as a three-layer system. Most current research focuses on the lower layers, trajectory planning, and autonomous driving. Our work targets the upper layer, vehicle sequencing, that is, deciding the optimal order for vehicles to pass at merging points. We aim to boost traffic efficiency at this strategic level. We initially tested our sequencing policies using a micro smart car platform. However, with only a limited number of these model cars, it's hard to simulate real-world scenarios involving hundreds or even thousands of vehicles. Therefore, we turned to simulation. We chose Sumo, a widely used large-scale traffic simulator. Here's one of our Sumo simulations. You can see that a better sequencing policy significantly boosts traffic efficiency. For example, our minimal switchover policy aims to reduce lane changing time as much as possible. As shown, it performs much better than the simple first-in, first-out approach. But here's the key point. This simulation assumes all vehicles are connected and automated. Studies indicate that real-world traffic will remain mixed with both automated and human-driven vehicles for at least the next 20 years. Now, here's a simulation of the same minimal switchover policy in mixed traffic. As you can see, human drivers often deviate from the planned sequence, causing significant drops in efficiency. To tackle this challenge in mixed traffic, we proposed a learning-based sequencing framework. Our approach used a transformer encoder to understand the complex interactions in the recent traffic state. Then, a PPO agent generates optimal sequencing weights based on this understanding. Simulation results show our PPO method outperforms both minimal switchover and first-in, first-out across different traffic demand and CAV rate. This holds true across key matrices like speed, traffic flow, and time loss. Thanks to IEEE Industrial Electronics Society and the IES Students and Young Professionals Paper Assistance Program.